Good morning, everyone. I'm Prasan Chapagai, and today I will be presenting a critical analysis of NoSQL databases with a focus on MongoDB. So I will explain why NoSQL became important, how it compares to traditional databases, and where it is used in real-world systems. So to understand NoSQL, we first need to understand the problem. Today, data is growing extremely fast from social media, cloud platform, and IoT devices. This data is not only large in size but also comes in many different formats like text, images, logs, and real-time streams. Now, traditional databases were not designed for this level of scale and flexibility. They mainly rely on vertical scaling, which means improving a single machine by adding more CPU or memory. But this has a limit and becomes very expensive. In contrast, modern system uses horizontal scaling, which means adding more machines to share the workload. For example, instead of upgrading one server, you can use multiple cheaper servers working together. Because of these challenges and needs, NoSQL databases were introduced. So traditional databases or RDBMS have been around since the 1970s and are based on structured tables and fixed schemas. They are popularly known for ACID properties, which ensures reliability. So let's break that down clearly. So A stands for atomicity, which means a transaction is all or nothing. To take as an example, in a bank transfer, money must be deducted from one account and added to the other account. If one part fails, the whole transaction is cancelled. C stands for consistency, which ensures the database always stays valid. For example, you cannot withdraw your money then more money than your balance. The system enforces rules to keep data correct. And I stand for isolation, which means multiple transactions don't interfere with each other. Even if thousands of users are performing actions at the same time, each transaction is processed independently. And this stands for durability, which means once a transaction is completed, it is permanently saved. Even if the system catches right after, the data will not be lost. So overall, RDBMS is extremely reliable, but it struggles when dealing with large-scale, flexible, and unstructured data. As system grew, companies like Google and Amazon started building new database model, and this led to the rise of NoSQL databases. NoSQL systems are designed to handle large-scale distributed data. They support horizontal scaling, flexible schemas, and high availability. One key idea here is schema flexibility. In traditional databases, you must define all columns before storing data, but in NoSQL, each record can have a different structure. For example, one user profile might include name and age, while another might also include hobbies or preference. This makes development faster and more adaptable. Um, so one common type of NoSQL database is document databases. They store data in JSON-like document instead of rows and columns. And for example, a user document can include name, skill, and status in one structure. The important thing is that each document can be different. And this is very useful in applications where data keeps changing, such as web apps, content management systems, or real-time platforms. So let's have an overview of MongoDB, which is one of the most popular document databases used in industry today. So it organizes data into databases, collection, and documents. So MongoDB has got a very core features like flexible schema, which allows different structures in the same collection. The other is indexing, which improves performance by allowing faster data retrieval, similar to how an index in a book helps you quickly find information. Aggregation allows complex data processing like filtering, grouping, and sorting data step by step. Replication ensures high availability by copying data across multiple servers. If one fails, then another takes over. And sorting enables horizontal scaling by distributing data across multiple machines, allowing the system to handle very large datasets. So let's compare RDBMS and NoSQL. So talking about schema, RDBMS uses a fixed schema, meaning the structure you must be defined before storing data, while NoSQL uses a flexible schema, allowing different records to have different structures. And secondly, scaling. RDBMS mainly uses vertical scaling while NoSQL uses horizontal scaling. Third is consistency. RDBMS follows strict ACID consistency while NoSQL often follows BASE, which we'll talk about in the later slide. And fourth is data types, in which RDBMS handle structured data like table with rows and column, while NoSQL can handle structured, semi-structured, and unstructured data like JSON images or graph. Fifth is query language. RDBMS uses SQL, which is called a structured query language, while NoSQL uses different query languages depending on the databases. Finally, the best case uses. RDBMS is best for system like banking or finance where accuracy is critical, while NoSQL is best for application like social media, big data system, or real-time applications. Um, So now let's talk about the CAP theorem, which is very important in distributed system. So CAP stands for consistency, availability, and partition tolerance. Consistency means all users see the same data at the same time. Availability means the system always responds to request. Partition tolerance means the system continues working even if there is a network failure between servers. So why do we actually need this concept? So because in real world system, network failures can happen. So designers must decide what to prioritize. For example, in a social media app, it is more important that the system is always available even if data is slightly delayed. But in banking, consistency is more important than availability. So CAP helps engineer design systems based on their priorities. And we have the best model. So NoSQL database follow this model instead of ACID. So BA stands for basically available, which means the system always respond even if the data is not perfectly up to date. Soft state means the data can change over time as updates happen. And it stands for eventual consistency, which means that although data may not be immediately consistent, it will become consistent after some time. For example, when you post something online, it might not appear instantly for everyone, but after a few seconds, it syncs everywhere. So talking about real world application, take Netflix as an example. It handles massive amounts of data like user activity, watch history, and recommendation, all happening in real time for millions of users. A traditional database would struggle to handle this scale efficiently. Amazon is another example. It uses NoSQL for managing shopping cart orders and product catalogs. And social media platform also rely heavily on NoSQL. Every like, comment, or messages is happening instantly, and the system needs to process or use number of writes very quickly. And in IoT systems, sensor continuously send data every second. So NoSQL databases are ideal here because they can handle high-speed continuous data streams. So overall, NoSQL is used in systems where speed, scale, and flexibility are critical. NoSQL databases are also strongly connected with cloud computing. Modern applications are built to run in the cloud, and NoSQL fits perfectly into this environment. For example, MongoDB Atlas is a fully managed cloud database. It handles things like scaling, backups, and monitoring automatically. We have AWS DynamoDB and Azure Cosmos DB, which provide global distribution, meaning your data can be accessed quickly from anywhere in the world. The key idea here is automation and scalability. This makes NoSQL very powerful and modern applications. So let's talk about the advantages of NoSQL. So first is high scalability. So because of horizontal scaling, NoSQL can handle billions of records by distributing data across multiple servers. Second is flexible data model. You don't need to redesign your database every time your data changes. This makes development faster and more efficient. And the third is cost effective. As I talked, instead of expensive high-end servers, you can use multiple low-cost machines. And finally, it is built for big data. It can handle structured, semi-structured, and unstructured data all at once. So overall, NoSQL is designed for modern large-scale applications. So there are some limitations as well. One major limitation is weaker ACID compliance. This means it may not guarantee full consistency like traditional database. And we have another issue like eventual consistency, security concerns, and learning curve. Because of this limitation, NoSQL is not suitable for every use case, especially systems like banking. So even though NoSQL is widely used, there are still some open challenges. First, security frameworks are not standardized. Each database handles security differently, which can create inconsistencies. Second, limited AI integration. Modern systems are starting to use AI for optimization, but NoSQL databases still lack strong built-in AI features, which can be improved. Third, consistency models need improvement. There is still a trade-off between performance and consistency, and finding the right balance is an ongoing challenge. So there is still room for research and development in this field. Looking ahead, we can see several important trends. One is hybrid databases, another trend is AI-powered database management. Security is also improving, and finally, cloud-native architecture are becoming the standard. To conclude, NoSQL is not a replacement for traditional RDBMS, it is complementary technology. Each type of database has its own strength and weakness. The key idea is to choose the right database based on the problem you are solving. In modern systems, we often use both together. This approach is known as polyglot persistence. That's all, guys. Thank you.